Let's take a look at this next question on work, pumping liquids out of a container. So this one is same kind of question, but different shape, of course. Instead of what we did in the previous one was the cone. This is a water trough. The ends of an 8-foot long water trough are equilateral triangles. So these are equilateral triangles like this, having sides of length 2 feet. If the trough is full of water, find the work done in pumping all the water over the top. So each of these sides is 2 feet, and then this is 8 feet long. So the volume is just going to be that rectangle times the 8 feet. So when you're looking at this one, the volume for that slab of water, when you make this little slab of water here, is actually that's going to be in the way. Hold on a second. So your volume is length times width times height. So what we want to look at and kind of calculate is the volume of this water trough. I'm sorry, not trough, the slab of water like that. So we can see that the thickness, again, is your delta y. Okay, so that's the height. When I say thickness, I mean that little piece, which is height. And then we have the length is 8, so 8 is the length. The width we'll figure out, and then you have your delta y. Okay, so we need to figure out what the length is. So if we drop this down again, call that x, then we can say that the width is what? Like how wide is this little piece, little rectangle? Before I move on, I'm going to take what I want to do. After what you do, even though this is three-dimensional, depiction, let's go ahead and draw in this, just the face, as a equilateral triangle. And I did it in advance to kind of speed things up. Just look like that. Didn't paste right where I want it though. Let's do it right there. So you can see you have the equilateral triangle like this. Okay, and it gives you a better idea because the length is just 8, so you don't have to really worry about that. And so each side is 2. That would leave that this distance here is just 1. Now that's at the edge. But in between, they're different, right? Like it's going to change as you take this slab versus this slab, right, as you lift that up and out. So we can figure out the relationship between x and y with this line again. Okay, so you can, this is a special triangle, right? So if it's equilateral and you basically cut it in half like this, then using Pythagorean theorem, you can figure out the height of this side right here. So that is the y value here, and it's root 3. So it's 1 root 3. So if you're not clear how to do that, set it up on your own and calculate that. All right, so then we have the line is mx, y equals root 3x would be the slope of that line, or the equation of that line. And then you can convert back and forth between x and y. So if you drop this down to here, that's your x, and that's your y. So the width of the whole thing, if this is x, then the width of the whole thing would have to be 2x. So you'd say this is equal to 8 times 2x times your delta y. But x is 1 over root 3y. So we don't want, we have to write this in terms of just y when our thickness for the slab of water is delta y. So it's ends up being 16 And then x is 1 over root 3, or just put 16 over root 3. Y delta y. Now, before we go on to finish this one, let me write up kind of the general outline of what you do. I have this started this down here. How to find work done in pumping liquid out of the container. Okay, so 1, draw a picture with a coordinate system which we did. 2, find the weight of a thin horizontal slab of the liquid. Okay, so find the weight, which will be a force, right? So it's the weight is the force, basically, of a thin, figuring out your delta y, then horizontal slab of liquid. Right, that's what we're doing. We're kind of doing that. So last time we have a horizontal slab like this, and basically you find volume, and then multiply by the whatever the weight is, or the factor is. In this case, it's 62.5. Okay, then 3, find the work delta W, just as an individual piece, it takes to lift the slab to its destination. It takes to lift the slab to its destination. Now I write it like that because the destination might be like 3 feet above the trough. Then you got to take into account that extra distance if it's like 3 feet above the trough. So let's look at our piece now. So this is really, let's see if this works. It usually doesn't, but I'm going to try it anyway. Oh, it worked. Very good. So that's just a little outline I wanted to do. Let's make it all look nice. So there's our outline of lifting liquid out. Okay, so now let's do our force. So our force is the 62.5 times the 8. Oh, I already made that 16. Let's just leave it as 16. So times the 16, and then y over root 3 delta y. That's your force. So now, what is our delta W? Okay, so it's like you're looking at the work for just that piece of slab, that slab. So just this. What would it be? Well, it's the distance times the force. The distance you lift this is the same as before, right? It's the height. Oops, sorry about that. It's this height, whatever the total height is, which is root 3, minus your y. You take off this piece, so that's what's left over. That's your height. So delta W is force times distance. So let's go ahead and write that up. And so that's the force, and then the distance then would be what? Root 3 minus y. So delta W is your 62.5 times 8 times 2, or 16, over root 3 y times root 3 minus y, delta y. I put the delta y on the end because that's going to be my dy when I evaluate. So so write this. So and then what are you integrating? So the work you're integrating, meaning you're moving those pieces from 0 to root 3. Now, I'm going to say this again because it's going to come up in your homework. If the distance above was, say, like 2, you'd have 2 plus root 3 minus y. But you're still only integrating from 0 to wherever the top of the tank is, because there's nothing else to actually throw out. Okay, but this is just the top of the tank, so we're not going to do that. But it will come up in your homework, so check that out. So we integrate from 0 to root 3, and I went ahead and multiplied all that out. You get 1,000 over root 3 y times root 3 minus y dy. Okay, so try that on your own, see what you get. And I'll give you the answer in a second. Just a polynomial, evaluating. It ends up being a really nice number. So you end up getting 500 foot-pounds. Take 500 foot-pounds to lift all that water up and out of the tank. If it was lifting it higher, then it would be more work to lift it higher, which of course makes sense, right? You're lifting a piece of slab higher. So you got to focus on this as lifting those slabs up and over the tank, and then it makes more sense. Okay, that's probably all we have for examples on work. We'll move on next to 6.6, which is moments and center of mass. Mostly focus on center of mass.